Hello everyone. Today we will see pre-envelope of a low-pass signal. The pre-envelope of a signal g of t, it is defined as a complex valued function and it is given by the equation g plus of t is equal to g of t plus j g cap of t, and we will take this as equation number 1. From this equation you can see the pre-envelope g of t, it is a complex valued function as we have here the imaginary part. So in this equation here g plus of t, it is the pre-envelope for positive frequency components of the signal. G of t is a real part of the pre-envelope and j into g cap of t, it is the imaginary part of the pre-envelope g plus of t. The pre-envelopes are practically useful in handling the bandpass signal and the systems. Now what we'll do is we'll apply the Fourier transform on equation number 1. So we get it as g plus of f. Small g plus of t will become g plus of f is equal to g of t will be capital G of f plus j as it is, and this g cap of t will be g cap of f. Now we will substitute for g cap of f. Here this equation will become as g plus of f as it is equal to g of f as it is plus j as it is. We are substituting for g cap of f. So this g cap of f will be minus j signum function into g of f. We'll take this as equation number 2. Now we will simplify this part of the equation, that is plus j into minus j will multiply. When you multiply plus j into minus is minus, j into j is j square and j square value is minus 1. So minus into minus 1 will be plus 1. So this part has become plus 1. So equation 2 will become g plus of f is equal to g of f plus, okay, plus j into minus j, it is plus 1 signum function into g of f. Now if you observe this equation, you can see here on the RHS side g of f is common in both the terms. So we'll take g of f common and we get it as g plus of f is equal to g of f is common and in bracket remains 1 plus signum function. So we'll take this as equation number 3. Now we know that the signum function is defined by this equation, that is it is 1 for all the frequency components greater than 0, it is 0 for f is equal to 0 and it is minus 1 for f less than 0. So what we'll do is we'll use this in equation number, we'll use this signum function value in equation number 3, that is we'll substitute these values in equation number 3. This was our equation number 3. When we substitute this, we will get g plus of f is equal to, okay, 2g of f. Now how we'll get this 2g of f? This here the signum function is 1 for f greater than 0. So what we'll do is for f greater than 0, we'll substitute here signum function as 1. So 1 plus 1 will be 2, 2 into g of f. Okay. Then next for f is equal to 0, it is 0. So again substitute f is equal to 0 here in place of signum function. 1 plus 0 is 1. 1 into g of f will be g of f. But instead of writing g of f, we will write it as g of 0 because here f value is 0. Okay. Next, for f less than 0, it is minus 1. So what we'll write, what we'll do here, we'll substitute signum function as minus 1. 1 minus 1 will be 0. 0 into g of f will be 0. So this is nothing but the pre-envelope for the positive frequencies. Okay. So from equation number 4, we can see that the pre-envelope of the signal g plus of t, it has no frequency components for all the negative frequencies. Okay, it has only the frequency components for f is equal to 0 and f greater than 0. It doesn't have any frequency components for f less than 0, that is for the negative frequency components. Now we'll draw the frequency spectrum here. So This is the frequency spectrum, or the or we'll call it as triangular. This is the triangular amplitude spectrum of the low pass signal. Okay, this is nothing but the low pass signal. This is a triangular amplitude spectrum. Now the pre-envelope of this will get here like this. That is, this is the amplitude spectrum for the pre-envelope for all the positive frequencies. That is, this part we are not getting here. Okay, why? Because for f less than 0, for the negative frequencies, this part will be 0. So we are getting only the right hand side part of this here. That is, we are getting only this part. Okay, here. So what will be the amplitude? 2 into g of 0. The amplitude is, the maximum amplitude is 2 here. So we'll get it as 2 into g of 0. This is the pre-envelope for the positive frequencies. That is g plus of f. Now it is also possible to draw the pre-envelope for the negative frequencies also. So we'll see that when we are going for the negative frequencies, the equation will be g minus of t is equal to g of t minus j into g cap of t, and we'll take this as equation number 5. In previous in the previous part of this, that is the pre-envelope for positive frequencies, we have written it as g plus of t, and here we were having plus t instead of minus t. But because we are going for the negative frequencies, this will be the form of the equation for the pre-envelope of the negative frequency components of the signal. So again, here g of t is the real part of the pre-envelope for all the negative frequencies of the signal. Then j into g cap of t is the imaginary part. G minus of t, it is a pre-envelope for the negative frequencies of the signal. Again, we will apply Fourier transform on this equation. The same step will be applied for this also. So this will be g minus of f is equal to g of f minus sign as it is j g cap of f. Now again, we will substitute for g cap of f here. So g cap of f is nothing but minus j signum function into g of f. So we have to simplify this. Minus into minus is plus, j into j is j square is minus 1. So now here we'll not get it as plus 1, here we'll get it as minus 1. So this equation will be now written as g minus of f is equal to g of f into, okay, that is here we'll get it as g of f minus signum function into g of f. So again, g of f is common in both the terms. We have taken g of f common, and in bracket remains 1 minus signum function. We'll take this as equation number 6. Again, we'll use the definition of the signum function and to substitute the values in the equation number 6 in order to get g of minus f. Okay, so again substitute 1 here for f greater than 0. Okay, when we are taking f greater than 0, we'll substitute 1. 1 minus 1 will be 0. 0 into g of f will be 0. Then second, f is equal to 0. Okay, for f is equal to 0, the value is 0. So substitute signum function as 0. So 1 minus 0 is 1. Then 1 into g of f will be g of f. But because here we are taking f is equal to 0, so we'll write it as g of 0. Next, we'll go for f less than 0. It is minus 1. So again substitute here the value of signum function as minus 1. So 1 minus of minus 1 will be plus 1. So we'll get it as 1 minus of minus 1 will be plus 2. 2 into g of f will be 2g of f for f less than 0. So when we draw the pre-envelope for the equation number 7, it will be like this. Okay, this is the amplitude spectrum for the pre-envelope for negative frequencies. Here you can see there is no frequency component for the positive frequencies. Okay, that is for f greater than 0, you don't have any frequency components. Okay, so this is about the pre-envelope of the low pass signal. Hope you have understood. If you have any doubt, you can write in the comment section. And please do like the videos, please watch the videos, and do subscribe and share. Thank you.